Okay, so what we have here is we have square roots and radicals. What we're going to do today is we're going to simplify our radicals. Now there's two properties that say that we can do this. If we have the square root of a times b, we can split that up. Okay, why would we even do that? Well, watch. If we have the square root of 9 times 2, right? We can split that up into the square root of 9 times the square root of 2. And the square root of 9 is special, isn't it? It's like a nice number. Yes, it's 3. And so we get 3 rad 2. So that's what we're going to be doing today. We're going to be kind of like reducing our radicals. You know how like when you were a kid and you were okay with 2/4, that was an okay answer. But really it's 1/2, and that's better because it's reduced. That's what we're going to do here. Instead of rad 18, which is what 9 times 2 started off as, it's really 3 rad 2 is what we want, okay? That property also works for, what's it called? Fractions, okay? Works for that too. You can split it up. So if I say have the square root of 9 over 4, I can rewrite this as the square root of 9 over the square root of 4, which is perfect, 3 over 2. Okay? Now they're not all going to be that easy. They're going to be a lot harder than that actually. These properties do not work with addition or multiplication. In other words, if I have the square root of a plus b, it is not equal to the square root of a plus the square root of b. It doesn't work with plus or minus. Just multiply and divide. Okay, so here are our rules. We have lots of rules in math, huh? I think that's why I like it. You hate rules. Rules are in place for good reasons. All right, so here we go. No radicands. Here's what we do for simplest radical form. That's what we're trying to do here. We don't want decimals. We want to write these all in like their reduced rational form. So no radicands can have perfect squares. What are perfect squares? Well, I listed some for you. Here they are. These are all perfect squares. What makes them so special is that if you were to take the square root of them, like the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, okay? So that's what makes them perfect squares. All right, so we can't have any perfect squares left inside of our radical. No factors of perfect squares. The other thing is you cannot have radicands that contain fractions. So see that number 5? That's not allowed. It's a rule. You can't have fractions inside of radicals. And then the last property is you can't have them in the denominator either. So look at that number 7 right there. Wrong. Okay? So those are the 3 things that we have to fix when we do these problems. All right? So here we go. Number 1. Change these radicals to simplest form.
2 feet.
Dang, you're fast. Stop it. Okay, so what we want to do is we want to figure out, we want to factor. Okay, we're going to factor this. But we want to factor it using its perfect squares. Is there a perfect square factor in 50? Yes. 25. 25 times 2. Am I right? 25 times 2. No, that is right. 25 times 2 is 50, and 25 is a perfect square. Now, why would I care about that? Well, look, I'm going to use that property that says I can take this and do rad 25 times rad 2. What is the square root of 25? 5. And the square root of 2 is the square root of 2. And that's your answer. Okay? If you were to go to your calculator right now, hi, calculator, and you were to take that and do the square root of 50, you'll get some ugly number. And if you were to do 5 rad 2, guess what? Same ugly number, right? Just like 1/2 is the same thing as 5/10. But you don't want to write 5/10. Nobody writes that. Nobody writes rad 50. You write 5 rad 2. You're like, I'm cool with rad 50. Anybody cool with rad 50? Yes. On the video, 2 people raised their hand. They're going to get -5. Okay, number 2. Here we go. So let's pull. If your parents are listening to this, like, she's crazy. All right, you're going to pull out some perfect squares from here. So let's look at the number 12 inside. Okay? 12 has a perfect square. What is it? 4. Yes, you need to know your perfect squares. 2 squared, 3 squared, 4 squared, okay? 4 times 3. All right, so here we go. We still have this 5 out here. I'm going to tell you what we're going to do with that in just a minute. Gosh, you're just ruining it for me today. No, you're doing great. I love it. All right, So we're going to take the square root individually. What's the square root of 4? 2. And the square root of 3 is the square root of 3. And then what is 5 times 2? Perfect. 10 rad 3. And that's your answer. That's the simplest one. Are you flipping over and doing the ones on the back? That's cool. So let's try number 3 now. Number 3. Now, 700 has a couple of perfect squares in there, but we want to pick the biggest perfect square. 25 is not the biggest perfect square of 700. What is the biggest perfect square?
100.
It's 100. This is 100 times 7x. Okay? That's our factors. We're factoring it into its biggest perfect square times the other numbers that belongs to it. So what's the square root of 100? 10. And the square root of 7x, neither one of those are perfect squares, so they just stay as rad 7x. Do you remember doing this as an Algebra 1 kid? Yeah? Yeah? Did you? Well, you're going to be better at it this year because it's the second time through. Okay, look at number 4. Number 4 has a problem. And the problem is that there is a fraction inside of a radical. So I'm going to fix that problem by using that property up there that says radical 2/3 is the same thing as radical 2 over radical 3. So I fixed one problem, but I created another one. My other problem is that I have a radical in the denominator, and not allowed to do that. So you can fix it, and here's the way you fix this. You're going to take whatever that radical is in the denominator, and you're going to multiply top and bottom of this fraction by it. Now, you can't just square a number, okay? Like, what if I say the number 4? You're like, no, it's 16. You can't just square something. Because someone in my other class is like, let's just square the bottom. You can't do that. But what you can do is you can multiply a fraction by 1. Isn't that just 1? Rad 3 over rad 3 is 1, right? So I get rad 2 times rad 3. Do you know what that is? Rad 6. And what is rad 3 times rad 3? Rad 9, which is 3. Perfect.
Can you not reduce that?
No, you can't. Yeah, some people think 3 will go into 6, which it does, but this isn't 6. This is rad 6. And 3 won't go into rad 6. Yeah, that brings me to another property that says this. If you have rad A times rad A, it's just equal to A. Okay? It's another property right there. For example, rad 141 times rad 141. Do that without a calculator. How about 141? Yes. Okay, so that's the property. So rad 3 times rad 3 is 3. If you forget that, just do it. Rad 3 times rad 3 is rad 9. Square root of 9, 3. All right, number 5. There are a few ways to do this problem, okay? And, you know, we can get to the same answer doing things differently, and that's great. But I want to show you the way I would do this problem. I would take this and I would split it up just like we did that last problem. Okay? Now, from this point, you can multiply top and bottom by rad 12 if you want to. But that's a big number, right? I would rather simplify rad 12 and get its perfect square out before I start multiplying things, okay? So let's do that. Rad 5, I can't simplify. That just stays as is. But what is rad 12 in its reduced, rationalized form? What is that? 2 rad 3. 2 rad 3. So it's 4 times 3. Square root of 4 is 2. And then square root 3. Okay, now I want to get that rad 3 out of there. Do not multiply by 2 rad 3. That's overkill. You don't need to do that. You can multiply top and bottom by rad 3. Okay? So let's go ahead and simplify this. What is rad 5 times rad 3? Rad 15. And then what number do I get in the denominator? 6. Yes? So do your rad 3 times rad 3 together is 3. And then times 2. And that would be your answer. There's no simplifying that. Nothing can come out of there. Yeah. Okay, let's split up number 6. Number 6 is going to be nicer. It's going to have a little shortcut. Have you guys been watching Stranger Things? No. So good. Okay. Brad, why did I just think about that? I don't know. I'm so excited. I want to watch one tonight. I watch just one at a time. You guys binge, don't you? Yeah, you watch like 5 in a row. I know.
spread it out.
I think so.
Did you
Yeah, I'm
enjoy
only
it?
on episode 5. Just watched it. The one that's out right now, whatever that is, the newest one. Second? Is it only second season? Yeah. Yeah, I don't binge. Nope. All right, there's too much sports on for me to binge watch that show. Tonight I'll be watching the football game. All right. Lions and Packers. Kings play tomorrow against your team, the Dukes. I call them something. Oh, no. Okay, here we go. Rad 3 over over 2.
Wow.
I call them the Mallards. What are you talking about? The Mallards. I know. Scory Perry. All right. Look at that. There was nothing, like, we could just reduce, and there it was, and we're done. So there's no fractions in our radical, and there's no perfect squares. All right. That was the first 6. Whew, lot to go. Here we go. Number 7. 6 over rad 2. This one right here, yeah, let's go ahead. There's nothing to reduce here. Rad 2 is in its smallest of forms, simplest of forms. So we're just going to multiply top and bottom by rad 2. Yes, we do. If you want to get it right. Okay, so you get 6 rad 2 in the numerator. And the denominator is 2. Now, is anyone like, wait a minute, there's one more little step. What is it? Yes, simplify, divide, same thing. Yeah.
3 rad 2.
Yes, 6 divided by 2, you get 3 rad 2. Very good. And you're on the video. Okay, you're YouTube famous.
Now I'm going to start getting these calls.
Yes. I haven't gotten any in a while, thank God. It's
Maybe
nice.
just want them.
Oh, that's right. I turned comments off. You're right. I thought I was doing better. I guess not. Okay. All right. Rad 6 over rad 2. You can multiply rad 2, top and bottom, but you know what you can also do? Simplify. Yeah, isn't that crazy? Rad 6 over rad 2. If we did that property and we did it the other way, that would just be rad 3. And that's our answer. I know. And you could spend time doing rad 2, top and bottom. You'd get there eventually, but it would take you a longer time. And I'm sure you want to spend more time on your homework, right? Number 9. Here we go. We're going to multiply top and bottom. Should I let you try this one? Yeah. No? Okay. I'll let you try this one on the back when you do your homework tonight. So we're going to do rad 3, top and bottom. Okay. You always choose what's in the denominator to do top and bottom. The radical? Okay. So up top we get 3 rad 21. 7 times 3. 21. On the bottom we get rad 3 times rad 3 is rad 9, which is 3. And then we can reduce rad 21. 21. Okay. Whew, halfway there. These are fun. Okay, number 10. Number 10, we do this for a reason. When we get to doing quadratic formula, we're going to get to doing quadratic formulas chapter, you'll get an answer like this, which won't be simplified, and you're going to have to simplify it. Okay, so I'm teaching you the simplified part. We'll do the quadratic formula later. So first of all, rad 20. Is there a perfect square in rad 20? It is 4. 4 times 5, okay? You just write it up top, that's fine. All right, so this 4 didn't change right there. This is rad 4, rad 5 becomes 2 rad 5 all over 2. Okay, unfortunately they're not like terms. You cannot add them. If this was 4 rad 5 plus 2 rad 5, then I could add that to 6 rad 5. Okay, but this is just a 4. So you can't add them together. So we're not going to do that. Okay, but we can do is we can reduce everything. See this? 4, 2, and 2. 4 is being divided by 2, and 2 rad 5 is being divided by 2. So let's take 2 goes into all of them. 2 goes into 4 twice. 2 goes into that 2 once. And then 2 goes into the bottom 2 once also. So we reduce our fraction that way. It is. Yeah. See these 4, 2, and 2? I divided all of those by 2. because they were all divisible by 2. So when you reduce your fraction, you have to reduce all the parts of the fraction. All right, let's try number 11. Rad 18. Any perfect squares in rad 18? 9. 9 times 2. Perfect. So I get 6 minus 3 rad 2 all over 6. Now, I taught this a couple of different ways today. I'm going to teach it this way, though, because I kind of like it better. You cannot just cancel out the 6's. So many people want to do that. Like, oh, let's just reduce the 6 over 6. But 6 is also being, or negative 3 rad 2 is also being divided by 6, okay? So what I want to do is I want to pick a number that will go into all 3 of those guys. What goes into all 3 of them? 3, that's right. So 3 goes into 6 2 times. 3 goes into that 3 once. You don't need to write a 1 out front. And 3 goes into 6 2 times, and that would be your answer. And once again, do not cross those out, okay? If you don't like that as the answer, you can write this as 2 over 2 is 1, and rad 2 over 2 is rad 2 over 2. Okay? But you can just leave it like that too. Either way is fine. I kind of like this better, but either way. Oh yeah, where you sit. You sit right there. Okay. Number 12. By the way, if you ever want to request the front to sit in your new seat, you can. You can't request the back, okay? And you can't request your best friend next to you. It just so happens that it happens. Although I did give Jacob and Fraley, shout out to Fraley. I gave them a chance to sit by each other because, you know. No, I don't know. We'll see. We'll see. All right, here we go. 12 is 4 times 3. 4 times 3. So this is negative 6 plus 2 rad 3 over 4. All right, so now once again, reduce what can be reduced. Take a look at those 3 numbers. Does anything go into all 3 of those? 2, yes. So 2 goes into 6 3 times. 2 goes into 2 1 time. And 2 goes into 4 2 times. And that's your answer. You can leave it just like that. That's completely reduced rationalized form. You need a paper. Here. There's some over there, too, that have been filled out in the front if you want to take a look at that. They're purple. Okay. We're almost done. Oh, not quite. We've got 6 more. These go pretty quickly, though. Okay? All right, so look at number 13. We're doing rad 2 times rad 14. Go ahead and multiply those together. And that gives us rad 28. Cannot leave our answer as rad 28. 28 has a perfect square factor in it. What is it? 4 times 7. Perfect. So this would be 2 rad 7. Nice. All right. 14 is to take 3 rad 5 and multiply it times itself. I'm going to write this as 3 rad 5 times 3 rad 5. Okay, sometimes it helps when you write things out. You make it look a little different, but it's still the same. So then what I do is this. I multiply the outside numbers together. So 3 times 3 is 9. Then I multiply the radicals together. Rad 25, which is, I heard someone say it, 9 times 5, which is 45. Okay, so we did 3 times 3 gave us 9. And then rad 5 times rad 5 gave us rad 25. But rad 25 is 5. And then 9 times 5 is 45. It's a lot of colors. All right, 15. Let's multiply these together first. Some people thought, oh, let's simplify rad 8, and you can, but I would just multiply it all together so you only have one radical to simplify. So this would be 7 rad 16. Ooh, that's nice. Yeah. 7 times 4. So rad 16 is 4, and 7 times 4 is 28. My age. 100 years ago. 82, my age flipped. Thanks. He's so funny. Number 16. Here we go. All right, square root of 100, a squared. 10. 10a. Yes, perfect. You guys are good. Bobby's about to say, wait a minute. You need some absolute values around that A, right, Bobby? Yep. I knew it. He was going to say that. Bobby, we're not going to do that. It's true. I know. It just overcomplicates things. We're just going to keep it simple. We're going to assume that our variables are positive. Bobby's about to die. Assume that your variables are positive. We're going to assume that, okay? I knew Bobby. I knew you were going to say that. That's so fun. I thought it all day long, too, and it bothered me to write 10a. It did. I wanted to write 10 absolute value of a. It's true. Because, look, what if a wasn't? What if this was negative 10 squared, right? And the answer to that is not a, because a is negative 10. It's the absolute value of negative 10, which is 10. Bobby's right, you guys. Okay.
Bobby, you're wrong.
Nope. Number 17. I'm going to erase this. Okay. Number 17, start by simplifying this first. So I have 3 x's up top, 1 x on the bottom. You know what you can do? You can reduce your x's. Wouldn't you like to just cancel out all your x's? That's fun. Oh, dang. Okay, so this really is 2x squared over 3. Okay? Everyone's okay with that? I reduced the x's. All right, and then I can split this up into rad 2x squared over rad 3. Okay. And then what is rad 2x squared? That's x rad 2 over rad 3. Because the square root of x squared is x, should be the absolute value. But that's okay. We're going to assume all variables are positive. And then right here at this point, we're not quite done. We still have that radical in the denominator, which is bad. Breaks our rules. So we need to multiply top and bottom by rad 3. So our final answer, we're finally done. We write x rad 6 over 3. Whew. Tough one, huh? Yeah, that was probably one of the worst ones of the day. And then we're finally here, the last one. You know what I would do here? I would simplify this. This is rad 16 over 50. And I know you see that perfect square and you want to do it right away. Don't. It's tempting. But let's reduce this. This would be 8 over 25. Okay? So what I did was I got all my numbers down to just their smallest form. I reduced all the way, and now I'm going to worry about the radicals. So this becomes rad 8 over rad 25. Let's simplify rad 8. Let's see if you learned anything today. So what is rad 8? 2 rad 2. Yes, you were doing it. 4 times 2. Take the square root of 4. Square root of 2 over the square root of 25. 5. There you go.